2015 was, let's see, number one. Do y'all see 2015 on here? Which column are you looking in? Okay. Number 5 scored an out. Well, we didn't do 5. We did 1 through 3. Any others? There should be 5. And there should be 6 of them on. Oh, yep, we didn't do 6 either. Okay, there's number 2. So remember this, because this and right beside it's number 1. These are the average amount of points students scored on these questions. I don't see question number 3. Oh, there it is. So these were pretty high scoring. They came. You see, column 1 is the lowest scoring. They're arranged by the order that students earned on them. So as you would grade yours and look at yours, I just wanted you to see that even nationally, I mean, you got 9 total points, and the average on these is not even half. Okay, so don't beat yourself up too bad. All right, here we go. I thought 1 was tough. 1 was tough until you understood what it was asking, but then from there, and then I thought the other 2 were pretty straightforward. But let's see what you did. The rate at which rainwater flows into a drain pipe is modeled by the function R of t. So here's my first function. Try to have all this ready for y'all. R of t is 20 sine t squared, and I really hope you let the calculator do 90% of the work on these. Cubic feet per hour measured in measured in hours between 0 and 8. The pipe is partially blocked, allowing water to drain. So I've got 2 different equations here. I've got a water in and a water out. You can see I marked those because I knew that was going to be important. There's 30 cubic feet whenever we started. Okay, so wrap your brain around the problem before you start trying to work the problem. All right, so the first part asks how many cubic feet of rainwater flow into the pipe during the 8-hour time interval. So that's into, so I just used my into equation and did the integral there. Notice this is a rate, which means this is the derivative that's being given to me. Okay, so to find the amount of water I needed, and you could look at the units too to know cubic feet per hour. Did y'all all pick up on that? Okay. So there we go. It's an integral. This was straight on the calculator. Did everybody get that one? I hope so. Well, I'm not saying too much. You got 1 point for the integrand there for this. You did not have to write out the whole integrand. You could have, since R of t is defined up here, and D of t, you could just put from 0 to 8 of R of t dt, but do not forget your dt, and then the answer. Can everybody do that on your calculator, or do you need me to show you? I will tell you that before I started on this problem, I began by coming over to my calculator. I knew this was a calculator problem. I went ahead and typed these 2 equations in my y1, and I left them in here so you could see, into my y1 and my y2. So I could just keep referencing those guys. All right, part B. They did not specify units on this one, so I would give it a point. In fact, on there, this is theirs, and they did not have the unit. They just said 1 for the integram, 1 for the answer. So 2 points there. Which could be why students were scoring higher on this than they were before. Yeah. I would hope that you would have a reader that would give you the points for that, but do try to keep your variables lined up whenever you go. Any other questions about that one? All right, part B is the amount of water in the pipe increasing or decreasing at 3 hours. Give a reason. So you have to remember that I'm looking at rates already, right? So I did it a little bit differently than they did it, but we came back to the same thing. So at hour 3, I need to know what the rate is. Well, the rate, I've got to take into account, and if I had to guess, this might be where you messed up. You have to subtract the 2. You have to take the water coming in and subtract out the water that's draining out, right? Because it's coming in, but it's also draining out. The question is it draining out faster than it's coming in? So am I decreasing or increasing on my level of water here at this particular time? So this was just, again, I've got it in my calculator. I just went to my table. I had these, I've got them turned off right now because I want to delete everything in here for you. Is that right? Maybe no, it's still right. Okay. Um, I just went into my table and I found those values at 3. Y1 is my R and Y2 is my D. And so 5.0864 minus the 5.4. I don't even have to say, it didn't ask me what is the rate. It said, is it increasing or decreasing? That's definitely a negative number, so I just put that it was less than 0, so it's decreasing at 3 hours. So if you considered, and this is how they worded it, did you consider that you had to use both R3 and D3? So did you, somewhere on there, did you do R of 3 and D of 3? That's the point. And then your answer with a reason is a point. And that's why I tell y'all always write something. Yeah. Well, they said, okay, so you did the integral. I would say since they said the amount, did you remember to add in that initial amount of 30 when you did it? It really doesn't matter though, because if they both got the 30. So you did the integral and then, okay, and you said that. I would think, based on how their scoring guide is, I would give you a point for the answer and the reason, but maybe not for the R of 3 and D of 3. And I don't know why that wouldn't be. That would be if I was reading that exam. That would be up for debate. I would fight for that point because technically that's. But seriously, that's. I mean, that's. You know what I mean? That's, you still understood the calculus. So, yeah. But based on their scoring guide, I would say that's 1 answer. All right, part C. At what time between 0 and 8 is the amount of water in the pipe at a minimum? And so this is the one that I got bogged down on. I spent the longest amount of time on this because I really just threw myself a loop on this one. And I'll show you what I did and what happened. But the first thing I did was I said, okay, it's asking me when's it at a minimum. I know that I have these are derivatives, right? So, and I kind of wrote my thought process here so that you guys could see. And y'all stop me if you have questions. The water in the pipe would be the initial amount plus the amount in minus the amount that's coming out, right? Well, how much did I start with? I started with 30. How much came in? Well, the amount that came in would be the integral of R of T. And the amount that flowed out would be the integral of D of T. Are y'all following all that? And remember, I've got this is Y1 and I've got this is Y2 in my calculator. And what I didn't do because I worked myself up into a tizzy on this one. This you could combine into just one integral of 0 to t and subtract them both in the same thing. You don't have to split it up into 2 different integrals is what I'm saying. Does that make sense? Okay. So I went around my butt on this, and that's what I was explaining to you. And I'll show you what they did, and they don't really have a lot of work either. I just did. I knew I'm between 0 and 8, right? And if this is my derivative function, I wasn't wrapping my brain around the problem. That's why I have so much work. Is I wasn't understanding what they were asking me and how to find what. So anytime that happens, I start doing massive amounts of work to try to figure out what I need to do. So here, I knew, and that's why I started out with this, because I was like, okay, I know I need that. What is that? What's happening? And then I went, okay, what's the derivative function? Because to find a minimum, I need to find the zeros of the derivative, which I did here, right? And I used my calculator to find that. So I graphed the derivative, remember I'm y1 and y2. y1 minus y2, and I found the 0 of that. Does that make sense? Okay. Did everybody get that 0 at least? Find that point. I know you guys. Okay, that's my minimum. That's my minimum time. It didn't ask me for a minimum amount, so I didn't have to find the y value, just the time that it happened. All right. And so, but in order to know, because it says when will it have a minimum amount, I have to include these endpoints also. And just finding these values at each of those is enough justification. You don't have to say it's increasing and decreasing or it's 0 or anything like that. These are enough. Okay, so here's what we're looking for. We're looking for, did you consider, at some point, did you know you had to subtract R of t minus D of t and set it equal to 0? So see how I did R of t minus D of t equals 0? That is a point. If somewhere on there you considered that, maybe you didn't solve it right, maybe you didn't. And this is why I tell y'all, show all your work. Let them go through and find where you did something that you were supposed to do to get your point, right? I've got all this work on here. I wasn't sure what I'd need, but I got that point for that because I did eventually include that. Your answer is 1 point. The answer is, well, where is my minimum? 3.2717 hours. You didn't have to show, it was calculator. You didn't have to. I was not wrapping my brain around this problem. Well, because the question said justify your answer. So anytime it says that, you need to put some justifying right there. And you can, okay, so you can, did you say it went from decreasing to increasing at this point? But it started with 30, right? So if it started, that would be right if it started with nothing. But because it started with 30, then I have to consider how it's coming in and how it's going out. At 0, right, I understand, yeah. I would say yes, since that's the same thing as RFT minus DFT for 0. That's the same. I mean, I would give you a point for, let me show you theirs. Okay, you see mine, you see what I did to show you how different it could be. So theirs is, they showed the value for each point. That's their justification, right? Is I checked, I set it equal to 0, I found where it equals 0, and I found each value here. Yes. Because remember, you got to check the endpoints, because I didn't start out with 0. I would say yeah. I would say probably yes for your answer, but not the justification. I'd give you one of the two. If you did it correctly. I'd probably give you 2 out of 3. This is the justification, finding the value. Oh, RFT minus DFT equals 0. That's 1 point. 1 point for the answer and 1 point for the justification. And then part D, I love set up but do not evaluate. Those are my favorites. It can hold 50 feet of water before it overflows. So I want to know, when will it have 50 cubic feet? So remember how we find that is my integral. I'm sure y'all are shocked to see that I did extra that I didn't have to do. This could have been combined into one integral. It didn't have to be 2 separate. But remember the amount of water we find, and I felt like if they'd have done part B before part C, I might would have understood part C a little bit better than what I did. Because then I would go, oh yeah, I'm just going to use what I did in part B for part C. But instead they went a little wonky with that one, but that's okay. So it's initial amount plus, and then you have to subtract the 2. Whether you split the integral up like that, or whether you put it together. See, they put it together in the same interval and set equal to 0. You got a point for the integral and a point for the equation. So 2 points. Yeah. Well, they say that because, let's see, water flows in and out of the pipe given rates. Because you still have to take into account how much water was in there at time 8, right? Because it's not 0. So I have to consider that, and that's why. If it started out like Madison was saying, empty at the beginning, or empty at 8, then I would go from 8 to W. But because at the end of 8 hours, there's a certain amount in there, and I don't know what that amount is. Now, if you knew what that amount was, you could say that amount plus, and then go from 8 to W. But I don't know how much is in there exactly unless I want to calculate that. Does that make sense? I would probably give you 1 out of the 2 there because I look at this as, this is 1 point. Whoa. And then the entire thing is a point, like adding and equaling. So I would give you 1 point for the integral there. Any other questions there? Mine? Yeah. Two, I tended to get lost in my calculator on 2, but I felt like it was a pretty straightforward problem. I do always label mine before I even start. I go ahead and label what's what. I also try, you'll see whenever we get down here, I try not to do much erasing on here so y'all can see what I do, and then I mark out what, even if I catch myself before I check it, which is what happens. Oh, y'all can't see that. Okay, anyway, so because I wanted to keep my equations in my calculator, that's my little scribbles up here. I wanted to make sure I had everything input so I could show y'all if I needed to on how to use your calculator to solve these. So I put g of x in y5 and I put f of x in y4. So that's just why I have a little mark. And I always, if I ever see these, the very first thing I do is I go ahead and calculate that intersection point because I know I'm going to need it. Okay. All that will help you. It will also help you if you label. Whenever I saw these, I saw that the graph on top was switching places halfway through, so I knew I was going to need to make note of that, so I made note of that as well. This one's G, this one's F, and then they switch whenever I get to F. So the first part says find the areas of regions R and S. Again, I'm just strictly in my calculator, and so for R and both S, so I'm going from 0 to 1.03, and that is, remember, just top curve minus bottom curve, right? And again, so I've got y5 minus y4. Do y'all need me to show you how to put that in your calculator? Whenever I did math integrate, and I'm going to show you. I kept hitting second enter, and pulling up these same equations that I need. If y'all don't use that tool on your calculator, you are losing time. Y'all don't know how to do second enter, so it pulls up the last thing that you typed in. Because I was subtracting these two, and this one actually is the squared one. This one's going to part B already. But I can keep hitting second enter, and it will keep going back to the thing that I typed prior to that, and then prior to that, and then prior to that. That way I don't have to keep calling up all these functions, and now I can just go in and just change 1 or 2 things as I need. And I know I've saved myself quite a bit of time over the course of this problem. All right, so the first thing I did was the integral from 0 to that intersection point. This is giving me R, right? And then from 1.032 over to, and they gave me this intersection point of 2, that's region S, and they swap places there. So I got 2.004. You got, this one was worth 4 points. I was really surprised because I thought this one was really easy. if you, no, go ahead, go ahead. What do you mean, Jeremy? So you want to calculate this and you want to take it out at least 3 or 4 decimal places. Mm-hmm. You're talking about right here, you just put 1. Check your intersection again. That intersection should be 1.0328, comma, 2.401. Check that intersection because I bet that's what went wrong. While you check that, let me give you the point breakdown real quick. You got 1 point for the limits being correct, meaning your bounds here. 0 to 1.0. So if you got those 4 numbers there, that's 1 point. Okay, if you don't want, here's what you have to do for that if you don't want to do that. Define that point before you start. Say A equals 1.0328. Once you define that, then you can come over here and say from 0 to A. They wouldn't give you points. You have to define. Yeah, you have to define it. They typically will define, and I'll show you how they define it and what they do. They will say, okay, this intersection point is this, and then every time they reference it from there, they just use that A and that B. They reference it in the very beginning of the problem. They'll use that all the way through for all the parts of the problem. So if that's easier for you, that's definitely an option. All right, so you got 2 points for the integrands themselves. So where you subtracted, you got your top minus bottom right, you got your dx. Your bounds, you already got a point for your bounds, so those are just integrands. So that's 2 points, and then 1 point for the answer. So that was a hefty problem that I didn't really feel like took a long time.